Now, Eric.
So if you really, really want to put a freezer that's not either GFCI or AFCI.
Hold on, let me think. You can have a freezer.
You put it in the laundry room 6 feet away from the sink. More than 6 feet away. So you don't need a GFCI, you don't need an AFCI.
So if you have it in a laundry room, yes, it doesn't have to be GFCI because only the receptacles within 6 feet of a sink have to be GFCI.
Got it.
Exactly. Now watch this. This is going to cause a lot of money because the average home probably has 20 15 ampere circuits. Ryan, do you think 20, 15 ampere circuits is reasonable for a house?
Yeah, depending on the size of the house, sure.
Yeah, I mean, but an average might be 25, it might be 15.
Sure.
Terry, do you think that's a reasonable number, picking up 20, 15 ampere circuits for all the lighting and receptacles in the house, not including?
I'd say 30.
All right, you're going to say 30, but let's go with 20 to 20. Let's go with 25. Make it easy, okay? On an average, bigger. So if you had, let's go with 20, easier. If you have 20 circuits, let's say 25. And in previous code, you had AFCIs only on 5 of them. Now what you've done is you've expanded AFCI circuits from 5 circuits, let's say now up to what? 25 circuits. So now you have 20 more AFCI breakers. Kevin, the average cost about 30 bucks?
For the branch circuit type.
How about the combination type?
It'll increase about 20%.
Whoa. So the combination types will be about $35?
Yes.
So 35 times 20, that's what, $700?
Yes.
But wait a minute, Mike, you had to buy the breaker anyhow. So let's say $10 for the breaker, so it goes up 35, minus the 10 bucks for the breaker you're going to pay for. That goes down to $25 per breaker. 25 times 20, that's $500. Listen, no electrical contractor is going to put it in without having to cover the cost of material. So let's just go with 20. Let's go with a 10% markup of material. So that's $500 plus 10%. It's $550. You're going to have overhead, and 10% is not anywhere near enough. But I'm going to make it easy. So let's just make it 10% of $550. That's $55. So now we're talking about $605. You have extra labor that's associated with installing them, and now you get 20 of them. He's going to have to figure out at least an extra an hour or two. So now you're going to talk about maybe another $50. So we up to like what, 550, 605. We're now about 600 and let's say round up $650. You need to have service. You're going to have to call for service. You have to figure in a factor for service work. So let's say 10%. That's another 65. Now you're up to $710. You got to have profit. I mean, no electrical contractor is going to put $700 worth of overhead and material costs without profit. So now we're talking about, let's just round it off to $800. Let's round it off to $750, $650. I don't care what we're talking about. We're talking a huge investment in cost here. Now, if I was a contractor and I got a 2,100 square foot house, how many circuits do I have to have for the house? 4, because you take 21 times 3, which is 6,300. You divide it by 120, came out to be about 53 amps. You divide that by 15, you know what? I can see a guy saying, you know, forget about that. I'm not going to put in all those circuits. What do I have to have? I'm just going to put in 4 or 6 or 8 circuits, and that's going to be it, and reduce that cost down that direction. It's a big change. Now, let's go on. There's a fine print note that's trying to make it clear that a single station smoke alarm not managed by a fire alarm control panel does not qualify as a fire alarm circuit, so AFCI protection is required. So if you have smoke detectors, and you connect, the best thing to do is have the smoke detector simply connected to the circuit that's the AFCI protected circuit, the smoke alarm. And we probably should have from that smoke alarm another circuit going off with that because it's connected to the other smoke alarms in parallel. Now, understand that this requirement, let's go back over here, only applies to the 15 or 20 ampere 120 volt branch circuits supplying outlets in these areas. So if you had a low voltage, let's say smoke alarm system coming off a burglar alarm system, well, those are not 120 volt circuits, so AFCI protection would not be required for that for obvious reasons. All right, continuing on the AFCI and dwelling unit bedroom circuits, there's an exception. The AFCI overcurrent device can be located at the first outlet if the circuit conductors are installed in rigid metal, intermediate metal, EMT, or steel type armor cable. Now, we've been talking about this combination AFCI, which senses the parallel as well as the series arcing fault. We talked about the signature and the waveform and all this stuff. And I showed you the picture, and I said it looks just like a GFCI. And we've been talking about breakers because that is what is currently available. The NEC has recognized since the 2005 code that you might want to get an AFCI protection device that is of the receptacle type. Now, the 2005 code had a similar exception, but they revised it for the 2008 code. But the bottom line is that there is no such thing as an AFCI receptacle. But if there were an AFCI receptacle that was of the combination type, then, let's read this again, then you could do it according to this exception. Then that receptacle, the AFCI overcurrent device, can be located at the first outlet if the circuit conductors are installed, rigid metal, intermediate metal, EMT, or type, or steel type AC cable. I'm not quite sure why MC cable is not permitted, but either it doesn't really matter because they don't make such a device, so we move on.